Okay, so for your bell work for today, Sarah went out to dinner and her total bill was $23.50. She has a coupon for 15% off and also has to pay a 20% tip. How much will her total cost be? Okay, so first we want to find 15% off of the total. So we have $23.50 and we're multiplying by 15%. How do we write 15% as a decimal?
0.15.
When you multiply these two values together, what do you get? So we get 3.525. When we're dealing with money, we want to round to the nearest hundredth, and this is going to round to $3.53. Do we add or subtract that from our total? Subtract.
I thought you only round the total.
You can wait till the end, that's fine. So when you subtract $3.53 from $23.50, what did you get?
19.98.
I think I should have gotten 97. So $19.97. And then we have to take that and multiply by 20% for our tip. 20% written as a decimal is 0.2 or 0.20. When you multiply those two values together, what do we get for the amount for the tip?
3.99.
And in terms of money, we want to round to the nearest hundredth. So this is just going to stay as $3.99. This $3.99, are we adding or subtracting it from our total? Adding, because it's a tip, it's an additional price we have to pay. And $3.99 plus $19.97 gives us a total of $23.96. Today's lesson is on one-step inequalities. We're going to focus on one-step inequalities by addition and subtraction. Your target is students will be able to solve one-step inequalities and graph a solution on a number line and write inequalities. Okay, for the notes, you can solve inequalities by using the addition property of inequalities. And the subtraction property of inequalities. Just like with one-step equations, when you add or subtract the same number from each side of an inequality, the inequality remains true. Okay, for example, if we have our first inequality, 2 is less than 4. If we add 1 to both sides of the inequalities, 2 plus 1 is 3. I bring down my less than sign. 4 plus 1 is 5. We added 1 to both sides, and 3 is less than 5, so the inequality remains true. If we were to subtract 1 from both sides, we have 6 is greater than 3. 6 minus 1 gives us 5. Bring down our greater than sign. 3 minus 1 is 2. Is 5 greater than 2?
Yes.
Yes, so our inequality remained true. Okay, our next vocabulary word is inequality. An inequality is a mathematical sentence that compares quantities. Solving an inequality means finding values for the variable that make the inequality true. Okay, our first symbol we have when you open to the right. So if you use your left hand, you can make your less than sign. It opens to the right. This symbol means is less than or is no more than. If your inequality symbol is facing the other way, that means is greater than, is more than, or exceeds. If you have a line underneath your inequality, it means that that value is also part of your solution. So this symbol we have is less than or equal to, is no more than, and is at most. Our answer for this one would be included in our solution. And the last one we have is greater than or equal to, is no less than, or is at least. Okay, before we go on to the next two examples, I just want to show you your rule of thumb for when you're graphing. If you have less than or equal to, you're going to use an open circle because your answer is not part of your solution. If you have less than or equal to or greater than or equal to, that's when you have the closed circle because it is part of your solution. You're including it in your answer. So when you see that line underneath, know that you need to fill in your circle. For our first example, number 1, we have a minus 3 is less than 8. You can set this up just like solving equations. If you want to split your inequality, you can. If we look on the left-hand side, we have a minus 3. How do we undo minus 3? Add 3 to both sides. Negative 3 plus 3 will cancel out to be 0. And we have a, I'm going to bring down my inequality, less than. And what is 8 plus 3? 11. So if we were to go ahead and graph this on a number line, I'd put my solution in the middle, so I'm going to start with 11. When you go to the right, your numbers are increasing, so I could have fill this in with 12 and 13. And when you're going to the left, your numbers are decreasing, so 10 and 9. When I graph this, would I have an open or closed circle? Open, because it's 11 is not part of our solution, so I have an open circle. And if 11 is less, or if a is less than 11, would I include 9 and 10 in my answer, or 12 and 13? 9 and 10. So we shade to the left because that's the part that makes our inequality true. Okay, for number 2, we have 4/10 plus y is greater than or equal to 7. If you split your inequality, we have 0.4 plus y. How do we get rid of 0.4? We're going to subtract 0.4 from both sides. This will cancel out. I'll bring down my y and my greater than or equal to sign. What is 7 minus 4/10? 6.6. And I want to go ahead and graph my solution. I'm going to put 6.6 in the middle. When I go to the right, my numbers are increasing. It's fine if I do 6.7, 6.8. If you're going up by a decimal, you can just, or if you have a decimal answer, you can have your number line increase or decrease by a decimal amount. And on the left-hand side, it'd be 6.5, 6.4. For this one, if I have y is greater than or equal to 6.6, would I have an open or closed circle? Closed. 6.6 is part of my solution. And if we want greater than 6.6, which way would we shade? To the right. We want to include the numbers that are greater than 6.6. So either way you want to graph is fine. You can do it above the number line or on the number line. Okay, to go over graphing some more, Closed circle means it can equal that number. That number is included in our answer or in our solution. An open circle means it cannot equal that number. And you always shade in the direction that makes the statement true. So if you look to the right, we have A is less than 1.5. What type of circle do we have on our number line? Open. Why did they choose that type of circle?
Because it's not included in our answer.
Yes, because it's not included in our answer, or because it cannot equal that number. It cannot be equal to 1.5. And why did we shade to the left?
Because it's less than.
Yeah, we wanted the numbers less than 1.5, so we shaded to the left because those include the numbers less than. When you're shading to the left, it's including the numbers that make the inequality true. Okay, go ahead and try the 3 on your own questions.